Okay, folks, here we go. Round two to finish up this piece on problem 41, where we're looking at this before and after on this antibacterial soap. Uh, let me start by showing you the manual computation. If you remember the test statistic, let me actually grab that test statistic for you and remind you of that. I'm gonna let's see, copy that and put it in here. So remember, this test statistic is based on the difference between the two sample means. Again, and there's an inherent relationship between the before and after in this case. So this makes this a dependent test of hypothesis. And then, so what we need here is we need to compute the average difference between these differences here. And I'll show you what I've already done that for you. And then the denominator, it's the standard deviation of these differences divided by the square root of the sample size. So just remember that as we go through that. I'll get that out of the way because I want to have a little space here. So what I have done in Excel here, and it's very simple, is I just go through and take the difference between the before and after. So B4 minus C4 in this case, and if I just pull that formula all the way down, it will give me all the differences for the 8 paired samples or paired observations. So the D bar here, the average of these 8 values is 3.1. That's the numerator. Then I can take the standard deviation of these 8 values, and that is the numerator piece of the big denominator divided by the square root of the sample size. So just keep that in mind. Excuse me. When you go through and compute this, and I recommend that you do it by hand one time. This one's fairly simple, especially now that you have all the values. So G5, which is D bar, divided by, that's kind of the big numerator, and then the denominator it's a fractional relationship, the sample standard deviation divided by the square root of 8. So the test statistic here is about 3.024 in that ballpark, depending on how the rounding happens. Now, so that would be the test statistic. You would go through and find the t critical value from the t table, and then you could do your comparison based on the fact. Let's see, one key piece here that let me go back and backtrack on just a minute before I say any more about the math. At the 0.05 significance level, can we conclude that the contamination measurements are lower after use of the new soap? So as you think about how you set up your hypotheses here, remember what you want to test here for. This will be very clearly a one-tail test. And if you want, if you want the contamination measurements to be lower after using the new antibacterial soap, obviously you will want, you will assume that they are not lower from the beginning. So just keep that in mind as you go through and set up the hypotheses. If there's any question about that, make sure that we can have post a note on the discussion board. We can have that discussion, but this will go back to making sure that you're clear here what it is you want to test for, and that is that the contamination measurements after using the new soap are lower than what you started with. So again, for now, you will assume that they are not. That will be the null hypothesis. So I think I've said enough about that to get you thinking along the right track. Now, let's see. I don't know that if I have ever shown you all this. I think I did. There's probably been a point at somewhere along the line. If not, let me show you here. If I go up to the data, tab at the top of the template here, or the ribbon here, over on the right hand side I have an option that says data analysis, and that's what we're going to need to do here in order to go through this independent test of hypothesis. If you don't see it there, I think I've shown you this before, but if not, let me just show you this. If you go to the file option on the ribbon and go down to options, you have this add-ins option here. And if you click on Manage Excel Add-ins and click Go, make sure you have the analysis tool pack clicked, and then you'll have this option up here to do all these neat statistical things that we want to do. So just click OK. If that, and I'm just saying, if that data analysis option doesn't show up when you click on data, just go through the steps I just showed you to add it, and you'll be in business. So in this case, what I'm doing is I have a paired test of variables where we're assuming unequal variances. So if I go into the data analysis tab, and let's see, I go down to these options are at the bottom. Let's see, I want to do a t-test for paired two sample for means. And this, when you see the paired, this is a dependent test opportunity here. Everything else down here would be for independent tests, depending on, let's see, what you're assuming about the variances, right? And that should be fairly straightforward here based on the tags that you see here. But in this case, we want to use this paired two sample for means, and let's get to it. So if I, let's see, all I got to do is follow the palette here, and I've already done it, but let me just clear everything out here. And I don't want that in E4 because I already got data there. Let me just go through this from the start. So what I want to do is I want to put in the variables. So I could put in variable 1, or the before for variable 1, variable 2. I can put that here, and then I'm going to assume right now. Now again, you know, right now we're going to assume that one of these is greater than the other, but it will be greater than or equal, or less than or equal to. So we can assume right now that the hypothesis mean difference is 0. Because I included the before and after, I want to say that I have labels, and I know my alpha is 0.05 here. So with this input, let me not say anything more. We'll see what the output looks like. The output range, we will put it here in cell, let's see, I think J3 should be okay. And if I move this down, I will get all the great data that I want to see here. So this will be the results that you will get from Excel. And I think you can use this to validate what you do for problem 41. And you can certainly use this for problems 48, 49, and then the Century Bank case. So let's see, the before, let's see, data gives you the mean, the variance, number of observations, and then you can take a look at the correlation coefficient between these two. That discussion is coming when we talk a little bit more about regression. Let's see, and then the same for the after. You have the sample mean, the variance, and then the number of observations. So you can see right away the mean difference certainly makes sense that the D bar, the difference in the two sample, or each, as you take a look at the difference in each sample, it makes very good sense that that difference would be positive, since these values seem to be on average much larger. And then as we go through the rest of this, hold on, let's shut my door real quick. Sorry about that. Let's see, what else have we got here? Number of degrees of freedom, like we said, since there are 8 data points and you have you have a dependent test, number of degrees of freedom will be n-1, so that's 7. The test statistic, 3.02392, I think that looks pretty familiar, right? So you will find your test statistic from Excel matches what we did here, kind of on the manual crank. And then let's see, this is very clearly a one-tail test. So the t-critical value, whether it be positive or negative that you're looking at, is 1.89. So if your tail test is a left tail test, you would assume that to be negative 1.89, and I think you get a pretty good indication of where your tail is based on the value of the test statistic. So you're basically at this point going to be comparing 3.0239 to 1.89. And I think what you will find is that you will be rejecting the null hypothesis. And like I said, if there's any problem setting up the hypotheses, once you take a look at this data, I think you will be able to set those up fairly easily. And then the data that you get will certainly jive, or your data or your results that you do from the manual crank over here that I think we've set you up pretty well with will match this. But the reason I want to show you this, like I said, is when you get to problems 48 and 49 and you're going back and using bus and baseball and century bank data, assuming that you're comfortable with the manual approach here, I think this will be very helpful for you to go through and get these sorts of statistics, and you will be able to make your conclusions based on what you're finding here. So I hope this is helpful. And like I said, if you're not seeing mean difference here, if you're not seeing the data analysis tab when you first open Excel, you know how to go through this file options, add-ins business down here to go ahead and add that, and then you'll be in great shape. And again, this is a good way to to verify any sort of written work that you feel like you need to do. But especially when you get into the larger data sets, this is fairly helpful for you to go through and make your conclusions. But again, the premium as it has been for the last 2 weeks now, it's being able to set up the hypotheses correctly. And if you do that, everything will flow nicely from there. So folks, I hope this is helpful. If you need more details, please don't hesitate to reach out. Hopefully this is enough detail to get you started, and it'll be smooth sailing on this homework. So good luck, and